Hi there, in this video clip I want to talk about metals, alloys and carbon structures. Let's look inside a metal to start with. I mentioned it before. It consists of these positive ions, there they are. They could be copper, iron, nickel, plus, 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 plus. And in between those layers, I've got electrons. Electrons are free to move. They're sometimes called delocalized electrons. So metals conduct two things, electricity and heat, and it's the electrons that transfer the charge and transfer the heat in the form of energy. However, if I mix two or more metals, I've got an alloy. An alloy is a mixture of two or more metals. It's common sense that metals have different sizes, and if I took a pure metal like that, don't forget it's a 3D structure. Graphics is not my particular thing, and there's a layer, and there's a layer, and there's a layer. If I subject it to deformation or force, that layer would slide that way, and if I took another layer and they subjected it to force, it would slide that way. So simply what I've said is the layers inside a metal are free to move. However, if I took an alloy, which I've said is a mixture of two or more metals, things like bronze, steel, cheap gold, etc. They're not so malleable, they're harder and stronger, and this is why. There's our matrix, our lattice of copper, and then I stick in something else. Different atoms, different metals have different sizes, and I put in that one there and that one there, and maybe I've got one here as well. So what I've got is metal one, metal one, metal one, metal one, 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 metal one, metal two. If I then try to subject it to force, I find that that movement that way is stopped, and movement that way is stopped. Let's not say stop, it's reduced. Therefore, the properties of a metal can be changed by adding other atoms which stop it being so malleable. It can, they're not so soft. Metals, gold is particularly, when it's pure, is soft. And alloying changes the properties. It makes them more usable, the stronger, the more durable. For example, if I took pure gold, it's sometimes called 24 karat gold, and then you get 14, or is it 12, I forget, 14 karat gold, and then I get 9 karat gold. This is pure gold, that is impure gold, and that is not that pure gold. But why they add things like nickel or maybe silver and copper to pure gold is to modify its properties. It makes it more durable, it makes it stiffer, it makes it less prone to oxidation and breakage, because the gold becomes stiffer, stronger, more rigid. because the movement of the atoms sliding over in a layer is curtailed or stopped. I want now to look at carbon. In a previous video clip, I mentioned that carbon comes in three types. You get diamond, you get graphite, amorphous carbon. Let's quickly go over that again. In carbon, it's a giant structure consisting of carbon and it's joined in tetrahedral structures. That's a 3D structure, by the way. And then that will be joined to another tetrahedron, and that's joined to another tetrahedron, and they're joined in 3 dimensions. So therefore, carbon is a giant molecule consisting of carbons joined in tetrahedral or tetrahedrons. There's lots and lots of bonds, so therefore it's difficult to melt, it's extremely hard. Graphite, another form of carbon, I've mentioned this before, consists of carbons joined in hexagonal rings. Hello, I can't count. 1, 2, 3, 4, 5, 6, is that right? 1, 2, 3, 4, 5, 6. I'm just checking I can count, and it's in rings, and there would be another hexagonal structure off there and another hexagonal structure off there, etc. And it happens that in graphite it has electrons found between its layers. So imagine that is a sheet of hexagonal rings of carbon, and that's another one and another one and another one. They can slip and slide between, so therefore graphite is good as a lubricant, but it's also got one more special property, because in between those layers it's got free electrons, and delocalized electrons are free electrons which can move. Therefore graphite is an electrical conductor. Poor old soot, charcoal, there is, consists of carbons and they're not linked or joined, they're all over the shop. It's got no definite structure and it's called amorphous carbon. In the old textbooks, these were called the allotropes of carbon, different forms of the same element but having different physical properties due to the structure. I want now to look at graphene. Graphene is single layers of graphite. Ordinary graphite consists of layers, but one single layer of graphite is called graphene. These graphenes are very thin, they're used in electronics, etc. They have special properties. I want now to look at fullerenes. 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 Carbon forms millions and millions of compounds, chemical compounds, and it's got lots and lots of different structures. We've seen 3, but imagine you've got like footballs, and you can get carbon in the form of a ball, and these are fullerenes, and these fullerenes can consist of hexagonal rings, 6 carbons, or 5 carbons arranged in pentagons, etc. 7 you can sometimes get them, And these fullerenes are very, very strong. And why all these things are strong is because there's lots of bonds you need to break. And the final type of carbon structure which I want to mention is nanotubes. I've mentioned that just mentioned fullerenes, you've got like football shapes, and they can all be in cylinders, like so. There's a cylinder, and what it is composed of is there's lots and lots of these hexagonal, or they could be 1, 2, 3, 4, 5, 6, 7 carbons joined together in rings. These rings are linked or joined together in the form of tubes, and these tubes are often called nano tubes, and they have great properties such as they are strong, they conduct electricity, and if something conducts electricity, it also conducts heat. What do you use these fullerenes for? Lubricants, reinforcement of materials, like if you take something that takes a lot of stick on it, a tennis racket, they're often made of these carbon, some books call it carbon fibres, which is true, but more specifically they are fullerenes. I'll be speaking a bit more about carbon. Carbon forms millions and millions of compounds, and I'll tell you why it's a little secret. It forms multiple bonds. It forms single bonds, double bonds, and triple bonds, and it's particularly fond of hydrogen. But I'll be discussing that in greater detail in a later or later video clip.